What if everything you thought you understood about power in the modern world changed in a single night? The events that just unfolded are not something that will fade into the background of history. They will be studied, debated, and analyzed in military academies for decades to come. Not simply because of the destruction they caused, but because of what they exposed about the real balance of power in the 21st century. In just 6 hours, an operation unfolded that forced the world to confront a reality many had ignored. Around 2,000 Iranian suicide drones filled the skies over Tel Aviv, turning them into something closer to a burning horizon than controlled airspace. This was not a minor clash, not a symbolic show of force, but a carefully calculated demonstration of capability. Critical military installations were hit. Systems that were once considered nearly impenetrable were pushed beyond their limits, and a shift in perception began to take shape. What we witnessed was not chaos, it was precision, planning, and execution on a scale that carried a clear message. The long-standing assumption of uncontested Western dominance in the Middle East is no longer as certain as it once appeared. The sequence began in the early hours of the morning, around 2:17 a.m. local time, when the first wave of Shahed 136 and Shahed 238 drones entered Israeli airspace. Inside the Polmachim air defense complex, radar operators saw something they had never encountered before. Their screens didn't just show activity, they were overwhelmed with it. Not dozens of incoming threats, not even hundreds, but thousands appearing at once from multiple directions. The attack stretched across a wide geographic front, from the Lebanese border down toward the Jordanian corridor, creating a scenario that existing systems were never designed to handle. Defensive infrastructure that was built to respond to limited saturation attacks suddenly faced a volume many times beyond its intended capacity. Algorithms struggled to keep up, systems became overloaded, and as seconds passed, gaps began to appear, small at first, then widening under pressure. What had long been seen as a highly reliable defensive shield began to show its limits under an entirely different kind of challenge. By the time the sun began to rise, the visual impact of the night's events was impossible to ignore. The skyline of Tel Aviv carried a darkness that had nothing to do with the early hour. Fires burned across the Gush Dan metropolitan region, an area central to both economic and military activity. These fires were visible even from aircraft flying at cruising altitude over Cyprus, a detail that quickly circulated through aviation channels and satellite imagery. Reports indicated that multiple major command facilities were no longer operational, and key infrastructure, including port logistics systems, had been disrupted. At the same time, movements were observed far from the immediate area of impact. In the Gulf of Oman, the USS Abraham Lincoln Carrier Strike Group, long recognized as a symbol of American military reach, adjusted its position, moving away from areas considered within range of potential threats. Satellite tracking picked up this shift quickly, and within hours, it became part of the global conversation. What makes this event particularly significant is that it was not sudden or unpredictable in its origins. It was the result of long-term preparation, strategic patience, and consistent development of capabilities that had often been underestimated or dismissed. For years, assessments in parts of the Western defense community leaned toward minimizing Iran's technological progress, treating it as limited or unsophisticated. That perception shaped expectations, and those expectations influenced planning. But what unfolded challenged those assumptions directly. History has shown repeatedly that when a nation invests steadily in self-reliance and is driven by sustained pressure, it can reach levels of capability that outsiders fail to anticipate. The outcome of this night reflects that pattern, a reminder that underestimating a determined actor over time can lead to results that exceed every forecast. Before we move deeper into the details of what happened, the tactics used, the technology involved, the broader strategic implications, it's worth pausing for a moment. If you're watching this, make sure to like and subscribe, because on this channel, we focus on analysis that goes beyond surface-level headlines. We look at what others avoid discussing, and we break it down in a way that helps you truly understand what's changing in the world around you. Share your thoughts in the comments as well. Do you think this event marks a turning point in the Middle East? Or is it part of a larger process that's still unfolding? Your perspective matters, and it adds to the conversation we're building here. Now, let's begin unpacking what really happened. Because behind closed doors, in government offices and military command centers around the world, a series of urgent questions are already being asked. How did such a large number of drones manage to overwhelm a defense network that costs billions annually to maintain? What does the pattern of targets reveal about the strategic intent behind the operation? Why did one of the most powerful naval forces choose repositioning over direct engagement? And how does that decision affect perceptions of strength and reliability? And perhaps most importantly, as the situation continues to develop, who holds the advantage in this region moving forward? The answers to these questions are not simple, and they carry implications that extend far beyond what headlines alone can capture. To truly understand the scale of what took place, you have to look beyond the number itself. 2,000 drones is not just a large figure, it represents a specific kind of challenge for any defensive system. Modern air defense is built around managing threats within defined limits, balancing detection, tracking, and interception in real time. Systems like Iron Dome were designed with particular scenarios in mind, where the number of incoming threats remains within a range that allows for effective response. But when that number increases dramatically, especially to the level seen in this operation, the situation changes entirely. Each interceptor requires time, coordination, and resources. When too many targets appear at once, even highly advanced systems can reach a point where they simply cannot keep up. The first wave alone consisted of hundreds of drones, following carefully planned routes. These paths were not random, they were designed to take advantage of terrain, minimizing detection time and complicating interception efforts. Some flew at lower altitudes, using natural features to reduce radar visibility, while others approached from angles that forced defenders to divide their attention. Mixed into this wave were faster variants that reduced the response window even further. In practical terms, this meant that operators had less time to identify, confirm, and engage each target. When multiplied across hundreds of simultaneous contacts, the challenge became exponential rather than linear. As the situation evolved, additional waves entered the airspace from different directions, timed in a way that increased pressure on already strained systems. By the time later waves arrived, defensive resources had already been partially depleted, and response times were slower due to the sheer volume of engagements. This sequencing was not accidental, it reflected an understanding of how these systems operate and where their limits lie. By targeting those limits directly, the operation was able to create conditions where even a well-developed defense network struggled to maintain effectiveness. What stands out most from the analysis so far is that the targeting itself followed a clear and deliberate pattern. The focus was not on random locations or purely symbolic targets, but on infrastructure that plays a role in detection, coordination, and sustainment. Radar installations, command centers, and logistical hubs were among the key points affected. This suggests that the objective was not simply to create disruption, but to reduce the ability to respond effectively during the critical early stages of the attack. In other words, the operation aimed at the system itself, not just the visible surface layer. And that is where the real significance begins to emerge. Because when a system designed to provide security is pushed beyond its limits, even temporarily, it changes how that system is perceived, not just by those who rely on it, but by observers around the world. What happened during those 6 hours is now being examined from every possible angle, and the conclusions drawn from it will influence decisions far beyond this single event. This is not just about what occurred, it's about what it means moving forward. As analysts began to piece together the sequence of events, one reality became increasingly clear. This was not just an attack defined by numbers, but by how those numbers were engineered into a system-breaking strategy. To understand it properly, you have to step inside the logic of modern air defense and see how quickly it can be stretched beyond its limits. Systems like Iron Dome are not designed to fail. They are designed with precision, optimized to handle a predictable range of threats with high efficiency. Under normal conditions, they perform remarkably well. But the key word here is normal. What unfolded that night was anything but. When thousands of incoming objects enter monitored airspace almost simultaneously, the system is forced into a state where prioritization becomes impossible to manage in real time. Every incoming drone demands attention, but the system cannot treat all threats equally when its resources are finite. That moment when demand exceeds capacity is where the entire structure begins to strain. The first wave alone, composed of several hundred Shahed, 136 drones, set the tone for everything that followed. These were not experimental platforms. They were proven systems that had already been tested in multiple environments. Flying at carefully chosen altitudes and following pre-programmed routes, they reduced the amount of time available for detection and interception. Each carried enough payload to damage or disable critical infrastructure, meaning that even a small number of successful penetrations could have a significant impact. But what made this wave particularly effective was not just its size, it was how it was layered. Within it were faster variants, including the Shahed 238, which introduced an entirely different dynamic into the engagement. By increasing speed and reducing the reaction window, these drones forced defensive operators into a situation where decision-making had to happen faster than human confirmation processes typically allow. This compression of time is a critical detail that often gets overlooked. In a standard engagement scenario, there is a sequence: detection, identification, confirmation, interception, and assessment. Each step takes time, even in highly automated systems. When that available time is reduced dramatically, the entire sequence becomes unstable. Operators are forced to rely more heavily on automated responses, and even those systems can become overwhelmed when the volume of data exceeds processing capacity. In this case, the combination of slower, terrain-following drones and faster, high-speed variants created a layered challenge that required the system to adapt continuously, something it was never fully designed to do at this scale. Then came the second wave, arriving after a calculated delay that proved just as important as the initial strike. This wave approached from different directions, using routes that had remained relatively quiet in the weeks leading up to the event. That quiet period was not accidental. It reduced the likelihood of heightened alert levels along those corridors, making the incoming wave harder to anticipate. By the time these additional drones entered the airspace, defensive systems were already engaged, resources had been partially consumed, and operators were dealing with the fatigue and complexity of an ongoing large-scale response. The timing created a compounding effect, where the pressure from the first wave had not yet been resolved before, the second wave added new layers of demand. By the time the final wave approached, the situation had shifted significantly. Interceptor inventories had been reduced, response times had slowed, and parts of the defensive network were already operating under strain. This final phase focused more narrowly on key regions, increasing the concentration of incoming threats in specific areas. At this stage, even partial penetration became more likely, simply because the system could no longer maintain the same level of coverage it had at the beginning of the engagement. The sound reported by civilians, the steady hum of incoming drones, became one of the defining sensory memories of the night, reflecting how close these systems had come to their targets. When post-event analysis began, the pattern of impact locations revealed something important. The targets were not randomly distributed, nor were they chosen purely for visibility. Instead, they aligned closely with components of the broader defense and support network radar installations, coordination centers, and logistical nodes. This kind of targeting suggests a level of planning that goes beyond immediate impact, focusing instead on reducing the effectiveness of the overall system during the engagement itself. By affecting detection and coordination early on, the operation increased the likelihood that later waves would encounter less resistance. At the same time, attention began to shift toward the technology behind these drones, particularly the evolution of the Shahed platform. For years, there had been a tendency in some circles to dismiss these systems as basic or unsophisticated. They were often described as low-cost alternatives, lacking the refinement of more advanced Western designs. But that characterization overlooked a key point. Effectiveness is not always about complexity. The Shahed 136, for example, is built around a simple but efficient concept. Its design prioritizes reliability, ease of production, and adaptability. It uses a combination of navigation methods that allow it to operate even in environments where traditional guidance systems might be disrupted. This kind of design philosophy emphasizes resilience over precision, perfection, and in large numbers, that resilience becomes a strategic advantage. Cost plays a major role here as well. Each drone can be produced at a relatively low expense compared to the interceptors used to stop them. When multiplied across hundreds or thousands of units, this creates a situation where the defending side must spend significantly more resources to counter each incoming threat. Over time, that imbalance can place pressure not just on immediate response capabilities, but on long-term sustainability. Even if a high percentage of drones are intercepted, the cost and resource implications of doing so at scale become a factor that cannot be ignored. The introduction of the Shahed 238 adds another layer to this equation. By increasing speed and refining certain design elements, this variant reduces the time available for interception, while also making detection more challenging under certain conditions. These changes may seem incremental on their own, but when integrated into a larger operational framework, they contribute to a system that is more difficult to counter effectively. It's not just about one drone or one feature, it's about how all the elements work together to create a cumulative effect. Another aspect that stands out is the level of coordination required to manage such a large number of platforms simultaneously. Launching and guiding thousands of drones across multiple routes and timeframes is not a simple task. It requires careful planning, reliable communication systems, and a degree of operational discipline that ensures everything functions as intended. The fact that this level of coordination was achieved suggests a capability that goes beyond individual components, pointing instead to a broader system of organization and execution. Navigation independence is also worth noting. In many scenarios, disrupting GPS signals is considered an effective way to reduce the accuracy of incoming systems. However, these drones appear to rely on a combination of navigation methods, including inertial systems and terrain-based adjustments, allowing them to maintain course even when external signals are affected. This reduces the effectiveness of certain countermeasures and adds another layer of complexity to the defensive challenge. What emerges from all of this is a picture of a system that has been developed with a clear understanding of both its strengths and its limitations. Instead of aiming for technological superiority in a traditional sense, it focuses on scalability, adaptability, and efficiency. This approach may not align with conventional expectations of advanced military technology, but in practice, it creates a different kind of effectiveness, one that is harder to counter because it operates on principles that are not always prioritized in more complex systems. And this brings us to a broader point. The development of these capabilities did not happen in isolation or under ideal conditions. It took place over years, shaped by constraints, pressures, and the need to find alternative solutions when conventional options were unavailable. That process, while challenging, can sometimes lead to innovations that would not have emerged under more comfortable circumstances. In this case, it resulted in a system that, when deployed at scale, was able to test the limits of one of the most established defense networks in the region. As we move forward, the focus shifts from what happened in the air to what happened beyond it. Decisions made at sea, movements that signaled a different kind of response, and the broader implications of those actions. Because while the drones captured attention, they were only one part of a much larger picture that continues to unfold.